Hi, welcome to Synoptic Meteorology Lab, and this is a presentation on surface visibility measurements. This is part of Lab 1. You need to view this to be able to answer questions and also to do Lab 1. So the first thing we're going to discuss is the definition of prevailing visibility. And there are actually two definitions of prevailing visibility. The first definition is the visibility that's considered representative of visibility conditions at the station. And what that means, this is the new definition. It came about as of 1996, so it's not so new, but it's relatively new. But what it means is that usually visibility measurements, the measurement of visibility is made by an ASOS or an AWOS machine. And whatever that machine measures, that's what the visibility is. So remember that AWOS or ASOS machines don't look around the airport. They only look right above them or in the very immediate vicinity. So the visibility measurement is over a very small sample volume. And it really can't determine what is around the machine or the sensor. So that's your first definition. The second definition is the one that has been around forever. The greatest distance an object can be seen and identified through at least half of the horizon circle, and that need not be continuous or contiguous. And what that means is with a human weather observer, they would look around and see how far they can see, the greatest distance they can see. So this is the definition that's been around since METARS, and also surface observations have been started a long time ago, and still it's used at locations where they have humans observing the weather. So let's take an example. Grand Forks, there is a human being that's making the observation as well as the machine. So what the Weather Service does is they determine the visibilities around the airport by objects that can be seen and identified around the airport. So here in this picture you see Grand Forks International Airport. Also you see the lovely lagoon to the northeast. And what these circles are, these are range rings that represent the distance from the weather observing site, which is very close to the center of the airport. And these numbers represent miles: 1 mile, 1 1/2, 2, 2 1/2, 3, and 4 away from the airport. When the visibility gets really poor, they need more objects around the airport that are really close to the weather observing site. So they start picking things like the end of the runway or a hangar or things like that. And these rings represent the distance away from the weather observing site in fractions of miles, statute miles. So for example, the FedEx hangar to the south from the weather observing site is approximately 5/8 of a mile. So if you can see the FedEx hangar, you've got 5/8 of a mile. Likewise, on the previous chart, there are objects that can be seen. For example, some of the objects that they use are things like there's a crane to the southeast of the airport that's about 1.5 miles away from the weather observing site. Or if you can see the Alaris Dome, then you know to the southeast you have at least 4 miles of visibility. So here's an example. Let's do some examples. Let's say that at Grand Forks the visibility is variable. It's down, the visibility is down. And in this case you can see range rings, and it looks like to the north the greatest distance that you can see by identifying, for example, the end of the lagoon and Kelly and the Kelly Tower and things like that. The greatest visibility you could see through the northwest, north, and northeast is 3 miles. After the weather observer goes outside and looks around, the greatest distance he or she can see would be 2 miles. Perhaps maybe they could see just a little bit past Highway 2, and they can see the bison farm and things like that. So by determining objects that they can see, they determined that the visibility to the north half of the airport, or to the north half of the airport, is 3 miles, and to the south half is 2 miles. In that case, the greatest distance, by definition, the greatest distance you can see through half of the horizon circle, the greatest distance would be 3. Even though you can only see 2 miles to the south, the greatest distance that you could see is 3, and by definition, that is your prevailing visibility, 3 miles. Here's another example. Sometimes we don't have the charts. This is what they do on the weather observing test. They just give you some examples like this. In this case, you can see the visibility to the north is only 1 mile. To the east and west it's 2 miles, but to the south it's unlimited. There's no distance that's reported. So the greatest distance you can see through half of the horizon, let's see, we'll start always with the greatest. And you can see unlimited to the south, but that's only 90 degrees. The next greatest is 2 miles, and you can see 2 miles to the west and 2 miles to the east. Each of those arcs are 90 degrees. Add those together, and that would give you 180 degrees. So the greatest distance you could see through half of the horizon would be 2 miles, and that is your prevailing visibility. Here's another example. In this case, the greatest distance that you can see is 3 miles on that outside ring, but you can only see that to the west. That's 90 degrees. Go to the next greatest visibility, which is 2 miles, and you can see 2 miles to the south, but to the west you can also see 2 miles. If you can see 3 miles, you can definitely see 2. So if you add those two together, the west sector and the south sector, that gives you a prevailing visibility of 2 miles. And then here's a simple example where you can see to the northwest at least 3 miles and to the southeast 2 miles. So the greatest distance you could see would be 3 miles. On the exam, it's kind of hard to draw those figures, so if I test this on the exam, you will see rings like this that show the visibility in each sector. And in this case, you've got 1/4 to the northwest, 1/8 to the northeast, 1/8 to the southeast, and 1/2 to the southwest. So if this is what the weather observer came up with as far as their observations, the greatest distance you start out with is 1/2, but you only can see that through 90 degrees. The next greatest distance would be 1/4, and you can see 1/4 to the northeast and 1/4 towards the you can see 1/4 to the northwest, and you can see 1/4, at least 1/4 to the southwest. You can see 1/2, but if you can see 1/2, you can see 1/4. So your prevailing visibility would be considered 1/4 of a statute mile. So that's what's put into our METARS, is the prevailing visibility, whether it's determined by a human being or a machine. Often you don't know whether it's being reported by one or the other. Of course, the greatest distance that can be reported by machines is 10 miles. That's just the limitation of the machine. Humans can see a lot further, but typically we don't report anything greater than 10 miles either. So that's what you'll see if you go to countries overseas. They report their visibility in meters, believe it or not. And then machines also can only measure visibilities down to 1/4 of a mile. If it's less than that, like if it's 1/8 or 1/16, they can't measure it that low, so they'll just tell you that the automated machine is making a measurement that's less than 1/4, but they're not sure what it is, and they use the M in front of 1/4 to indicate that. That's all I have for you for this lecture, or this segment of the lab.